Hello, my name is Mark Pimentel. I'm a CAM application specialist here at Hawkridge Systems, and in this video I'll be showing you how to create a 5-axis chamfering operation. So typically for parts like the one we see on screen, either sheet metal parts or thermoforming parts, before we take it off the machine and have it handled by anyone on the shop floor, we want to deburr it, just for safety's sake, but also maybe for fit and function sake as well. So we're going to add a 5-axis chamfering operation to make sure this is deburred when we take it off the machine. So let's see how I've set this up before we get into the operation. Because we have a part that is a little oddball, it's not going to be made out of square stock or bar stock or anything like that. We need to have a unique stock definition. For simplicity, since I'm just going to be deburring this, I just define my stock as the part itself. So whether this was a translated file or an original SolidWorks file, kind of doesn't matter. What we're doing here is we're just defining the part we see on screen as my stock. One thing to note, this stock does not have any chamfers on it. If it had chamfers on it, then what we would be doing is actually defining it as just a simple operation following that chamfered surface. So really this operation we're about to see in this video is for when you have the model still with sharp edges. We're looking to deburr those sharp edges. In terms of the features, I have two multi-surface features I've defined. Feature 1 is the actual surface we're going to be using in our operation, and that is just those yellow sidewalls that we see on the side of the part there. And the fact that they're yellow made it really simple to select them. I just did a selection by color, and then it shows all those side surfaces. Feature 5 is all the top surfaces. I'm actually going to be using this twice. I'm going to use this to define the trajectory of my 5-axis toolpath, but I'm also going to use this later as my gouge checking surface. If we jump to the actual operation, we're using a multi-axis mill operation, and I'm using a 45-degree half-inch taper mill, but you can use a chamfer mill here as well. The only difference is you got to make sure that you give it an end diameter. Even though this one has a little tiny one here, I'm kind of approximating it as a chamfer mill anyway. The purpose here is that end diameter will give it a little bit of a radius, a little bit of an offset, so that it knows the direction that it should be offsetting for some of the stuff we're going to do later to make this a chamfering operation. If we take a look at pattern, I'm using the offset from surface. So if my yellow surfaces highlighted on the screen are my active surfaces, then to find the edge that I'd like to follow, I just need to choose those top surfaces. Those two surfaces together interface at that top sharp edge, so that becomes the trajectory of my toolpath. My direction, I'm just going to be using a zig pattern, so that's going to be a one-way cut. And under cut direction, I have it set to conventional only because when I first generated this under climb, it went to the right. It went in a counterclockwise direction. So that basically didn't give me the climb milling I'm looking for. So in 5-axis, a lot of the times when you see cut, direction, climb versus conventional, you can think of it as just a binary selection, just 1 or 0. So if climb went the wrong direction, when I set it to conventional, it goes in the correct direction. So this will actually output with a conventional cut. The limits, the method I'm using is number of cuts set to 1. And the reason is because if I'm defining my trajectory as the interface of those two surfaces, then that becomes the single cut that I want to do. I'm not looking to do any kind of step over. The actual step over is not going to be used here when I set this to 1. I'm looking to just do a single pass of my deburring operation. This is a rather large part, and I probably want to start it at a certain point, so I've used my start hint, and I've just selected this vertice right here. That way I can get it to do my entire 5-axis toolpath, but starting at that point. I want to start it at this straightaway, that way I can make sure everything looks good when I start and enter into the part. Speaking of entering into the part, entry/retract, I'm just using a lead-in of an orthogonal line. So at this point, everything is pretty much the same as what you would do with every other 5-axis operation. If we take a look at the tool axis control here, I'm using a 5-axis output, and I'm using a side tilt in the tilt relative to cutting direction of -90. And again, this is just kind of a binary selection. When I first put in 90 degrees, meaning I wanted the tool to be tilted perpendicular to the surface normal of those yellow surfaces, it was pointing downwards. So I just made it -90 and it points upwards like you see on screen. orthogonal cut direction to each position. I just wanted it to be perpendicular to the surface as it goes along. I didn't want it to be following the isolines of the yellow surface. You can see that the isoline would be kind of on an angle there. So overall, again, very similar to 5-axis. We're using a tapered mill here. It has kind of an angled surface. So by setting it to 90 degrees, we're actually getting it to almost do an approximation of a swarf cut. But what you'll get when you use this sort of tool is it'll be offset by the diameter of the tool. So the tip of the tool will follow that line, and it'll be offset by a little bit of either my 5 thou or by the full 1/2 inch, depending on how you define your point on your tool. But that means it's just going to kiss that line. Any control we're putting anywhere here currently will just kiss that line. It'll follow that line. You can imagine if you were doing this as a regular 5-axis, you were probably trying to follow that line to trim this part or machine out a surface or whatnot. Deburring actively is gouging the part. So we need to give it a little bit more of a parameter to gouge the part. And that's what we're going to do in the finish section. In the finish section, I'm giving it an allowance. So you can see from the graphic that is just a distance away from the active surface. In our case, the yellow surface, the sidewall, we're giving it an offset of 5 thou, meaning we're going to just pull it out along the surface normal by 5 thou. So that's going to almost act as my radial shift. Depth along tool axis, that will drop it along the tool axis direction. We are doing a 5-axis simultaneous toolpath, which means we're going to be dropping it in this direction. So that is effectively a radial shift and an axial shift. And you'll notice the numbers are a little different, and that's because even though we're trying to gouge the part, we still need to kind of control exactly how much we want to go down to achieve the amount of chamfer we're looking for. And the numbers are very simple to calculate. So in this case, I'm giving it a 5 thou allowance. I want a 20 thou chamfer, so that means I just need to drop it by that 5 thou. And the 20 thou, because again, if I just made these numbers similar, I'm just going to be moving along that tapered wall. I'm still going to be kissing that corner. So I want to gouge it a little bit, so I need to drop it by that much. And that's an easy calculation there. If I want a 20 thou chamfer, I need to put the 20 thou in there, negative 20 thou, and then an additional drop of the allowance. That way I can get it to drop and give me the exact chamfer I'm looking for. So with all that being said, let's get out of here. And let's actually take a look at this. So if I go into Simulate, again, you can see my stock is the original part. We see the sharp edges there. I'll just step through the code a little bit here just to see what we're doing. So the tool comes down from that retraction plane. It's into position, lead in, and there's our first cut. You can see it's going in the climb direction. If I run this for just a little bit here, what we're going to get is trimming of the entire part. And you can see there's some tilting going on there as well. If I left this as is, it would tilt orthogonal to the cut, all the parameters we just put in here, but we have some internal corners and we have some tight areas in there, and that needs to be accounted for as well. So I'm just going to run this all the way to the end, and then I want to show the chamfer. And the reason I did 20 thou, probably not the best deburring chamfer, but I wanted to show it because I know the height of those sidewalls is about 40 thou. So we can just see that, yes, exactly, that looks like it's 45, and that is about 20 thou depth right there. So this is an easy way to get that 5-axis chamfer. And whenever you're doing this sort of work here, you always have to make sure you're not gouging the part. So let's see the gouge settings I put in there. As we saw, there's some tilting going on, especially in these corners. And the way I got it to automatically avoid everything for me is in gouge checking. I told it to just make sure everything except for the flute is gouge checked. Because if I check the flute, I can't gouge the part. I can't deburr the part. So I'm just making sure that everything else clears. And the way I'm getting it to do that is if it gouges with the feature surfaces, so those are the ones I selected as the feature, or the active feature, and the other surfaces. Other surfaces being, again, that top surface. So if I'm making sure I'm not gouging either of those with anything that is non-cutting, anything that would actually rub or deflect the tool, my strategy is to tilt the tool and then to tilt it in the lead lag direction. The lead lag direction, if you go back to the axis control, that's just leaning in or leaning away from the cut. So in our case, as this thing goes around the corner there, it will tilt either away or into the cut. What that actively will look like is if we go into the step through, let's just go by position. So if I bring this all the way, let's go back to the beginning here. So I'll just reverse the path here. So as you can see, it is orthogonal to the cut up until the point where the holder might touch. So it begins to tilt. And the holder might be enough to make sure I don't gouge, because as you can see, there's some distance there. But just in case, I also included the other bits there so that as it goes along, it makes sure that this also doesn't gouge right here. So that is the leaning away, that's the lag. But also now you can see that that could also collide as well. So I'm just going to add a lean in as well. Now it's going to start to basically tilt away, or make sure that it stayed tilted away from the orthogonal. And then as it gets to the straightaway, you can see that it becomes orthogonal once again. So with the gouge checking, we can get it to automatically check all those things for us by just telling it which surfaces we'd like to avoid. So all of this together allows you to create a 5-axis simultaneous toolpath that, by the use of this tapered tool, will also do some chamfering. Basically, actively gouging the part to deburr the part. Any questions of this or anything else, just give us a call at the main tech line found on our website. If you like these videos, please like and subscribe to our YouTube channel, and thanks for watching.